Have you ever wondered if there's more to activating a relay than just flipping power? Turns out, there is. Let's explore. Here we have a top brand 3-phase relay with a 24-volt AC or DC coil rating. Now, watch as we apply 24 volts. The relay activates, as expected, but it's drawing 170 milliamps. That might not seem significant, but it equates to over 4 watts of power. In an enclosed space, that heat adds up, risking not just the relay but the entire system. Imagine scaling that up to 10 relays or more. We're suddenly looking at over 40 watts of heat generation. Surely, there must be a more efficient way. Lowering the voltage reveals that the relay remains operational, consuming progressively less power, until it disengages at around 7.5 volts. Interestingly, reactivation requires a surge over 13 volts. There we have it, activating a relay demands more power than maintaining it. By applying just 8 volts, about 30% of its rated voltage post-activation, the relay operates on a mere 360 milliwatts. That's less than 1/10 the power at nominal voltage, dramatically reducing heat, allowing more relays to function concurrently, while using a smaller power supply. Throttling the relay's voltage can be achieved through pulse width modulation, PWM, a technique where we modulate the voltage by adjusting the on and off time of repeating pulses. For our demonstration, we'll be using the EQSP32 wireless controller, connecting the relay to one of its 16 I/O lines, each capable of PWM. We'll ask EQAI, our tailored GPT model for the EQSP32, to turn on the relay and dial the power down to 35% after 100 milliseconds, to stay on for 5 seconds, then off for 2, in a repeating cycle. EQAI, with its detailed understanding of the EQSP32's capabilities, swiftly provides the optimal code. We simply transfer this into the Arduino IDE, compile, and run. As expected, the relay commences its on-off cycling. Through an oscilloscope, we see the relay's initial burst of energy at 24 volts for 100 milliseconds, before transitioning to PWM at 35%, stabilizing the voltage at 8.5 volts as can be seen on the voltmeter. Monitoring the power supply reveals that with the relay off, the EQSP32 alone draws about 30 milliamps. Engaging the relay spikes the current to over 140 milliamps momentarily, then levels out at around 50 milliamps. With PWM on, the relay's additional draw is a mere 20 milliamps, approximately half a watt, demonstrating the contrast in power required to activate versus maintain. This principle of tiered power application is essential for efficiently operating coil-activated devices, like water or pneumatic valves and solenoids, ensuring both energy conservation and operational integrity. 2 more details. When applying PWM to a coil, a flyback diode must be included to maintain proper current flow and avoid voltage spikes. Also, when activating multiple relays simultaneously, there should be a slight delay between each to prevent a cumulative power surge. The EQSP32 includes diodes on each outputs and handles the sequencing automatically. Curious to explore more? Have questions or insights? Drop us a comment below, and let's continue the conversation. Don't forget to subscribe for more practical tech tips. Thanks for watching.